Hello everyone. So today in this video we are going to solve a question of LeetCode. There is container with most water. This is 11th question on LeetCode and this comes under medium category. Alright, so let's start with problem statement. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I comma 0 and I comma height I. So basically in this question we have given an array and in this array there are values of height. Alright, so these heights represent the vertical lines in the xy plane. So find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. So basically we need to return the maximum water which a container can store choosing these lines. Alright, so we need to form a container using the height of the lines given. So we need to return the maximum amount. So the first thought comes in our mind is we can choose it greedily. So let's see how can we use it greedily. So let's say we start using the two pointer approach here. Alright, so let's say initially we have taken two pointers. First one is L and second one is R. Now L is pointing to leftmost side and R is pointing to rightmost side, or we can say rightmost index. So initially L is 0 and R is the size of the array -1. Now Lth index is 1 and Rth index is 7. So what we will be doing here, we will be calculating the area of this. So let's say the area of this is, let's say there is no lines in between, and the water it can hold is this one. Alright. So the water this can hold at this point of time is this one. So what we are doing here is that we will be calculating the area of this area. Alright, so the area of this rectangle is, the height is 1 and width is 1, 2, 3, 4, 5, 6, 7, 8. Width is 8. So area is 1 into 8 is equal to 8. So area of this rectangle for L equal to 0 and R equal to size -1 is 8. Now this is not the maximum area which it can hold. So let's check for other conditions. So if we choose it greedily, what we are doing here is that we need to maximize the area. So to maximize the area, definitely we need to increase the height of the pillars, or we can say height of the lines. So if we need to increase the height of the lines, what we will be doing here is, let's say initially these L and R at 0th in this position, and now we need to increment or decrement any one of them. Like we need to increment the L or decrement the R. So to increment or decrement these values, we will be choosing greedily. So to choose it greedily, what we will be doing is that we will be incrementing or decrementing the value of minimum out of them. If L is less than R, like the Lth value is less than R, so we will incrementing the Lth index. Or if Rth value is less than Lth value, then we will be incrementing, or we can say we will be decrementing Rth value in this case. So in this case, Lth value is 1 and Rth value is 7. So definitely Lth value is less than Rth value, so we will be incrementing Lth value. So L will come here. Now L is pointing to this point. So let's calculate the area for this. So the minimum out of them, Lth index and Rth index, is this one. Because we are taking minimum, because if we take this area, then water will overflow from here, the extra space. That's why we need to take the minimum out of them. So let's calculate the area of this rectangle. So area of this rectangle is, this is 7 and this is also 7. 1, 2, 3, 4, 5, 6, 7. The width is 7 and height is 7, so the area is 49. Alright. Now let's check for another condition. Now another condition could be, let's check, we need to increase the area now. Okay, so what we will do, we will just increment or decrement the minimum out of them. So minimum out of them is R. So we will be decrementing R. So R will be coming here. Now R is pointing to this index. So let's calculate the area for this. So the area for this is, let's say it is forming a rectangle here. So height is 3, width is 1, 2, 3, 4, 5, 6. So 6 into 3 is 18. So the area of this for this L and R is 18. Let me write it here. It's 18. Alright. Now let's check for other conditions. So other condition could be, let's say we need to maximize the area. So we will be just decrementing or incrementing the minimum out of L and R. So definitely Rth index is minimum because R is 3, let Rth index is 3 and Lth index is 8. So let's decrement R. So R will be coming here. Alright. Now the height of R is 8 in this case. Let me just draw a rectangle here. So yeah. Now height is 8 and width is 1, 2, 3, 4, 5. So let's calculate the area. So height is 8 and width is 5, so area will be 40. Alright. Now let's calculate for other conditions. Now these both are equal, so we can decrement or increment any one of them. So let me just clear this and yeah. So R is here as this point and we can increment or decrement any one of them. So let's decrement R for now. Alright, so we are decrementing R, so R will come here. Now let's calculate the area for this rectangle. Area for this rectangle is, the height is L and width is 4. 4 into 4 is 16. Now the another area is 16. Let's calculate for other condition. Again we need to maximize the area, so R will decrement, R will come here. It will form this rectangle. 5 into 3 is 15. Okay, let's calculate for other conditions. Again we will be decrementing R because R's index is less than L's index, so R will come here. Calculate the area for this rectangle. This is 2 into 2, that is 4. Let's calculate for last condition. Now R will come here and this will form this rectangle. So area for this rectangle is 6 into 1, that is 6. This is 4, the previous one. So the maximum out of them, all between all this value, among all this value is 49. So we will be returning 49 in this case. So this is basically a simple two-pointer and greedy approach. So I hope the approach is clear to you. Let's quickly code it up. Alright. So let's take two pointers here, int L equal to 0 and R equal to height dot size -1. These are basically the leftmost and rightmost pointers. Now let's run a while loop until L is less than R and also take a variable int answer equal to 0 which will be storing the maximum area. Alright, so let's take area for each condition. So let's store in a variable int area is equal to minimum of height L comma height R into width, so width will be R minus L. Now let's update our answer with the maximum area, so maximum of answer into area. Alright, now let's increment or decrement R based on the value of height. So if height L is less than height R, then we will be incrementing L, otherwise we will be decrementing R. Alright, at the end just return answer from here. I hope it should be fine. Let's just run it. Yeah, it's working fine. Let us submit it. Yeah, it's working fine. So let's calculate the time and space complexity of our solution. So the time complexity of our solution is big O of n because we are traversing through all the n elements, and space complexity of our solution is big O of 1 because we are using constant spaces here. So I hope the solution is clear to you. If you still have a doubt in this question, feel free to comment it down. Please like this video, subscribe to our channel. Thank you.